This Zoom session, oops, let me try that again. This Zoom session is being brought to you by the Fractal Bullseye, one of my favorites, by the way. Okay, we start chapter 3, which means that since we finished last Tuesday, so chapter 2 is due after next Tuesday, and there is a quiz 1 covering chapters 1 and 2 due after next Thursday. All right. This right now is about inverse sine, inverse cosine, and inverse tangent. All right. We start. The inverse sine has a graph like this. You can think of it as the graph of the sine function going up the y-axis instead of the x-axis, and only a little piece of it from here to here to make it a function. Y equals the arcsine of x, aka written as sine inverse x, if sine of y equals x. Well, this -1 means inverse function, well, at least a partial inverse. Unfortunately, I'm not entirely happy about that because it makes it look like it's the reciprocal of sine, which it is not, but so be it. Think of it this way. If we have a circle, unit circle, and you go distance x, in this case negative, along the y-axis, then find then draw this line, which meets the circle where at this horizontal line of value x. See where it meets the right half of the circle. There's also a left half, but we ignore that. So this angle between minus pi halves and pi halves is y, the arcsine of x. Part of the definition of arcsine is that sine of the arcsine of x equals x for, well, basically any x. Any x between 0 and -1 and 1, but those are the only ones that make sense. And arcsine of sine x equals x, a little more complicated for x between minus pi halves and pi halves. Unfortunately, an angle, say here, would also have the same arcsine, the same sign, so it's not perfect. That's the trouble. It's not a unique function, unique inverse. Arc cosine of x. This looks like a piece of the cosine graph marching up the y-axis. This piece of it to make it a function. Here the idea is we go a distance left to right, in this case left, a distance x along the x-axis. We raise a vertical line and see where it meets the upper half of the circle, not the lower half. And then this angle is y, the arc cosine. Written arc cosine or cos inverse. Again, this -1 means inverse, not reciprocal. A arc cosine is one whose cosine is x. So cosine of arc cosine of x equals x for basically any value of x that's applicable. Arc cosine of cosine x equals x for x from 0 to pi radians. And again, here we have uniqueness problems. Here we have the graph of the arctangent x, arctan or tan inverse. It's a little piece of the tangent graph written marching up and down the y-axis. It's this branch of it to make it a function. Arctangent is an angle whose tangent is x. Here we draw a unit circle, draw this tangent to it, go a distance x, in this case negative along that vertical line, draw this diagonal where it meets x, and this the angle between minus pi halves and pi halves is y, the arctangent. It's an angle whose tangent is x. So tan arctan x equals x for all x. Arctan of tan x equals x for angles in this part of the curve. If we try some of the circle, if we try this, it doesn't quite work. So, for example, what is the arcsine of -1? Well, draw a unit circle, draw a line -1, y equals -1. This angle here is where it meets. That's at angle of negative pi halves, -90 degrees. Arcsine of √2/2. Well, okay. So here we draw the isosceles triangle, side √2 here, and diagonal 2. Its sine is √2/2. The angle is this one in the right half of the circle, 45 degrees, aka pi/4 radians. Here they ask for the arctangent of -0.4. Well, here there's no obvious answer. So the calculator how will give it to you to 6 decimals, negative 0.380506. Arctangent of root 3. Go over 1, up root 3, and this diagonal is 2. So this angle is the arctangent. This is a 1 root 3, 2 triangle. This angle here is 60 degrees, also known as pi over 3 radians. Arc sine of negative 0.12. Again, no obvious answer. But the calculator gives it to 6 decimals, negative 0.120289. That's in radians. One thing you should note is if you go run to a calculator, you'll have to make sure that the mode has a mode button, which tells you, among other things, whether you're working in radians or degrees, and you have to make sure which it is. Otherwise, you might give an entirely wrong answer. Here, they asked to invert f of x equals 5 sine x plus 2. Well, I'm content with saying give an inverse because, like I say, arc sine, these don't invert quite nicely as all that. No unique key. So y equals f inverse, one of many, means f of y equals x. So 5 sine y plus 2 equals x. Solve for y. Subtract 2, that's easy. Divide by 5, sine y is y, x minus 2 over 5. And then inverting, you get arc sine of x minus 2 over 5, but that's one of many solutions. There are, in fact, infinitely many. And that's a difficulty that we'll be discussing later. Just a second. All right. Here, asked to solve 4 arc sine x equals pi. So arc sine is pi over 4. Here we can, without difficulty, take sine of both sides and get x on the left side. Sine of pi over 4, which is sine of 45 degrees, root 2 over 2. Here it's 4 arc cosine minus 2 pi equals 2 arc cosine. All right, the trick here is to subtract 2 arc cosine and add 2 pi to both sides. 4 arc cosine x minus 2 arc cosine x equals 2 pi. Left side simplifies to 2 arc cosine x equals 2 pi. Divide by 2, arc cosine x equals pi. You can take cosine of both sides and it inverts to an x here, to cosine pi here. So x equals cosine pi or negative 1. Well, okay, that's that for that. Next time, we'll be going over more about inverse trig, arc cotangent, arc secant, arc cosecant. Arc cotangent is arctangent of reciprocal. Arc secant is arc cosine of reciprocal. Arc cosecant is arc sine of reciprocal. We will also go over things like trig functions of arc trig, and there are various diagrams here that explain, quickly give you the necessary formulas. And we'll see more about that next time. All right, then. Let's see. Stop share.